Good afternoon, everybody. Today I will discuss some of the numerical problems which are based on the Kirchhoff voltage law and see some of the examples of KCL also. So first, what is KCL? Okay, KCL. It is Kirchhoff current law. It is a Kirchhoff current law. It states that at a node, the sum of incoming current and outgoing current from a node is equal to, it states that at a node, Kirchhoff current law. Good afternoon, everybody. Today I will discuss on the topic, and that is KCL and KVL, and we will see some of the numericals based on the KCL and KVL. So first we start the topic KCL. What is KCL? How to apply the KCL in a given network? How to solve the problem based on the KCL? So we will discuss first today. So first, what is KCL? It is given by a scientist named is Kirchhoff's. So it is Kirchhoff's current law. Now the Kirchhoff current law states that at a node, sum of incoming current is equal to sum of outgoing current. This is statement given by the KCL. So now, as you know that this is a suppose a node represented by this dot sign. Now suppose current I1 is coming at a node, and this is I2 current is entering at a node, and this is also entering the node, which is I3, and this is outgoing of the node, that is I4, and one more, this is I5, which is leaving the node. Okay, so these are the five coming five branches, or we can say these currents are coming at a nodes. So we, from the above statement, we can write that I1 is incoming plus I2 is also incoming plus I3 it is also incoming. Okay, now we will see that how many branches are leaving the node. So here I4 and I5 both are leaving the node. So at a node, sum of all the incoming current as well as outgoing current at a node is equal to always 0. Now we will see that you have given a question and you have to calculate the current at node A. So this is your given question, and the value of this branch, suppose I1 is equal to 5 and this is equal to I2 is equal to 4, this is your I3, it is given 2, and this is your I4, it is given to you, it is equal to suppose 4, and this is given to you. It is I5 of 1 ampere. These all are the currents which is given to you, and now you have to find the current at node A, and it is also given as, so as we know that I3, it is a combination of I1 and I2. I3 is a combination of I2 plus I1 is equal to, and now further we will add this I3 plus I4 plus I5, and this will give you 5 plus 4 plus 2 plus 4 plus 1. This is equal to 9, 10, 16 ampere. This is the current at the node. This is a basic about the KCL. नोड पे करंट हमेशा जीरो होता है, वो हमने यहाँ पे. Now second thing, proceed towards the next topic, and that is KVL. This is Kirchhoff voltage law. Kirchhoff voltage law. First, it states that the algebraic sum of all the voltages dropped in a closed loop circuit is always equal to 0. It states that algebraic sum of all the voltages dropped in a closed loop circuit is always equal to 0. This is summation of all the voltages in a closed loop is equal to 0. So now we will see and we will apply the above. This is given you the first second problem based on KVL. Suppose this is a given circuit, this is a given circuit, and here a battery of 12 volt, here plus minus, this is the positive terminal, this is the negative terminal, this is the resistance of 2 ohm, and here resistance of 6 ohm is connected across the circuit. Now as you know that voltage will be dropped across the 2 ohm resistance, and that is equal to, suppose we write this is V1 across 2 ohm resistance, and here V2 across the 6 ohm resistance, and we consider that current always flow same in the series circuit. So this is the direction of current we have assumed here, and now we can write the equation by using the KVL, and this will be equal to 12 minus, this is the plus terminal, this is the minus terminal, and this is the plus terminal, this is the minus terminal. So we can write 12 minus 2 into I, and minus 6I is equal to 0. So this is 12 minus 8I is equal to 0. Then 12, it can be written as 8I. So I is equal to 12 by 8, and it is equal to 6 upon 4. This is 3 upon 2, and it can be written as 1.5 ampere. So we get the current that is equal to 1.5 ampere. This is the current I is equal to 1.5 ampere, which is flow through the given elements in the circuit. This is the current which is flow in the above given circuit. Okay, so we have calculated the value of I. Now we will find the voltage V1 across the 2 ohm resistance. This will be V1 is equal to I is flowing through the 2 ohm resistance, so V1 is equal to I into, suppose we can write this R1 and this R2. So it will be equal to I is equal to 1.5 into R1 is 2. So this is equal to 3 volt. This is the voltage across the 2 ohm resistance, and V2 is equal to IR2, and it is equal to 1.5 into 6, and it is equal to 9.0. This is the V2 voltage. So we have conclude here. Conclusion, we have find, we get the value of. Okay, now we will see one more problem of question based on